we can start with the lab 8.
Yes.
Okay. I'll present my screen. Okay. I hope you all are doing well in your life, because we are approaching the end of semesters, and I can see that the participants for this class decreases quite significantly. So if you know your friends who are in this class but they didn't attend, please tell them. Although it might not be so obvious, but attendance will matter. Yeah, I'm afraid that if you or your friends do not get enough attendance, then you might have problem graduating from this subject. Yeah, so if you know any friends who are in this class but they didn't attend, then tell them to. Right. So we will go to the lab 8, which is sorting. Okay, so the first question is about merge sort, but the condition for merge sort is a little bit different. But the only thing different is only the things that we use to compare, where the odd number is always smaller than the even number. So even though, as you can see after the merge sort, even though 95 is pretty large number, but it still lies before the even number. So even number has some priority over odd number. Right, so this is the only condition. I believe you all have already known what is merge sort, but still we can go through the pen again. Right, so provided we have an array. So this is merge sort, yeah? Array of 5 items. Okay, so how merge sort do the work is divide and conquer. So it will it is a recursive method that will keep on dividing our array into half. So let's say if we have odd number, let's say our algorithm is the left side will be having more items than the right side, right? So we can divide like this. Oh no, not like this. Okay, so one thing is that we can have a look at this algorithm first. Okay, so as you can see, the recursive method of the merge sort, the stopping condition is when our left side is more than or equal to right side, right? Because these things are wrapped inside the condition. So if anything outside the condition, they will not be executed, which is what we call as the stopping conditions for the recursive method, which when left is more than or equal to right. Right. So here we call it once, we get the middle point and we call the merge sort once, and another time is at the right side. So we divide the array into half. We go to the left side first, then only we go to the right side, then we will try with merging. But what is with this condition is that although when you are drawing the merge sort, you might draw like this first, okay? But in actual case, it is not going to execute the right side first, because recursive method, right? Recursive method will always go down into the deepest method call. You reach the stopping condition, then only you traverse back. Then only you execute the next line. So what will happen is that here is 3, right? So you go to the left side first, become 2. Yeah, 2, another one. We don't go there first. And another time we go to the left side. Okay, now you reach the end already, where your L is equals to R. Right, you only have one item. There's nowhere for you to divide already. So now you have reached the stopping condition for this node. What we will do is that you will traverse back, you'll go back to the previous method call, and from here, you call the second line, right? Until now, we get the middle point and we call the first line only. Then now we call the second line for the second last method we call just now. Yeah, to a previous method we call just now. And second line is dividing by here. And also we reach a stopping condition where L is equals to R. Then from here, we will also go back to the previous one. And what we will do is that the third line is it will merge the array. What I call it as merging is actually only sorting. Yeah. So provided L, M, and R, we are doing the sorting. Right. So what the sorting will do is that it will merge the two children here. Yeah, it will merge the two children into a sorted array. Okay, so the magic behind this sorting algorithm is that we are referring by reference. Okay, so we can do this sorting by interfering with the original copy of array. So the original copy is here. The reference is always going to be this array. Then when we are doing the sorting, we are going to sort the original array. So these two things, right? These two location is exactly the same as these two location, then exactly the same as this two location. So after we have done this merging, these two will be sorted already. Okay, then now we have terminated this method call. Then we will call the previous method again. So this previous method is only one, right? So when it is only one, it's obvious that it also achieved its stopping condition already. So now it will go back to the previous method call and call the third line. The third line will merge these two things into three. Right. So now this also being sorted. And we'll go to the right side again. And stopping condition reach, and try to merge. Not try to, it is a must for it to merge. Then this will be sorted already. Then you're done. How to say? Just now I did a wrong thing that I mentioned that this two is sorted, but it is sorted within this range only. Yeah. For example, like 0, 1, only 0, 1 is sorted. Then 0, 1, 2, only 0, 1, 2 is sorted. Then this is 3 and 4 will be sorted only. Then only it will do a overall sorting for the rest of the for the both sides of results. Yeah, you do an overall sorting. Then you will achieve a sorted array. So by thinking the diagrams as an actual program, it can ensure that you will not confuse whether you want to put 2 here or you want to put 2 here, or when you are doing the merging, if there's a even number case and odd number case, where you want to merge them. If you are confused about it, try to think from the program perspective, from the algorithm perspective. Okay, they are the same actually. The behavior of recursion is that you won't stop until you reach a stopping condition. Yeah. So let's look at the code base. So this one, I retrieved from the, later you can see. I think when you are searching for merge sort, probably similar algorithm will occur. Right. Dividing, and concur. Concur means solve the subproblems. Okay. So the definition of concur is, in our case, is to merge and sort the array. Right. The algorithm for merging is actually pretty simple. First, because we have a middle point, so we are dividing it into half again. Then we are putting into a new, two new array. The reason we are putting is that we don't want to lose track of any of the items we want to sort. we want to ensure that the result of these locations that we mentioned is sorted. Right. So if we don't make a copy, later we might because we are referring to the only copy. We only have one copy of ARR, this variable. So okay, this is a syntax of C++, which I don't. This is for Java. Then if you put it here, it's for, in my opinion, it's for C. This array, then you are swapping, you're doing swapping and so on, then you might lose track of any of the items that you want to sort, right? So you are making 2 copies here, and after you make 2 copies, now you have 3 index that are referring to the location of AR, location of your first array, and location of your second array. The new arrays. So while these two are less than the length, it means both of the lists still have something to put yet. Now you will try to compare the location of this left and right array, and which one is less than you put inside the k. So k is your the index of your original array. You put inside the k, then you increment I. If the left side of the I index which is originally 0, so let's say in your left index you have 1, you have 2 and 1. The right index, the right array, you have 3. So at first, both will be starting from 0 and 0. So now, your result array will be not sorted yet, so I didn't put anything here yet. And if this is smaller than this one, or it is equals to this one, then I will put the item inside the array. But here it's impossible to be unsorted because we are doing the divide conquer, right? Divide and conquer means before we reach into this stage, we already solved the subproblem of the array. So it doesn't make sense for it to be unsorted, right? So now we are comparing 1 and 3 and looking at which one is smaller. We put a smaller here, and the index will be from 0 become 1. And take note that the j index, this one is I index, will become 1. The j index will still be 0. And the k index will be your lower, this is L, lower plus 1. Okay. No matter what, your original array index will be incremented by 1 because we know that every operation, either we will put the item from L inside the array, or we will put the element from R inside the array. So the second step, let's say the second iteration, this one is still having 1 item, then right is also having 1 item. So we still under the condition where both still have items to compare and to proceed with this iteration. The second step, 2 is still less than 3. So what we'll do is that here will become I plus 2. And here I equals to 2. Right, so when I is equals to 2, it means that there's nothing already from here we want to we can put inside the original array. Now we get out of this condition already, but there's still something left over, which is what we are doing here in the 2 while loop. The first while loop is we are checking if there are items in the left side yet. Then if there is, we just simply put inside the original array. But since they are already empty, so we are not putting anything yet. And the second loop is to check the right array, right? To check the right array. Now we have 3 here. We still have 3 here, so Now we will put the 3 at the end of the array. So at the result will be sorted. The j will equal to 1 and the k will be l plus 3. So at the end you'll get a sorted array in the that particular range it will be sorted. So why is this working? Okay, so the first thing we're doing is that if both have items, right? If both have items, we are doing it by comparison. So comparison will ensure that whatever we are putting in the original array, it will definitely be sorted. Right? This is confirmed, it will be sorted. But the rest of the conditions is we have either one have items and another one is empty. Because when two are having items, we already solve it here, right? So when we are get out of this loop, it is confirmed that either one will be empty and another one will be occupied, or might be occupied and might be empty. So this two while loop is to ensure that we are not leaving anything out. So let's say if left has any item left, then yeah, we just simply put it will be sorted. The reason is that if this can be simply put, it is confirmed that this is empty, right? So if this is empty, this might be having something to put, something like this. You can try to print out the steps. You try to print out the steps to see what is actually happening underneath. Why is merging like this can solve the problems, right? So from my view, I think that this merge sort is something like it might be wrong. I might be wrong. Yeah, I think that it might be something like a bottom up approach in which we solve the bottommost condition first, right? One item we sort it, then we ensure that the sublist is sorted, then only we merge with other things. Okay, that will be from the smallest problems we solve it, then get to a larger one, and eventually we merge the solutions into a complete solution for sorting, right? Like for example here, after we divide all into one item, we start to solve the smallest subproblem first, right? We solve this subproblem, then we solve this subproblem. After we solve it, the second layer we also solve the right side, and after this, we will get a complete solution by merging the solutions we have. Okay, so why am I keep talking about the algorithm but not the comparison requirement, right? Here it mentioned that the odd number is smaller than the even number. So because all the sortings are the same, where we compare is another thing already. So it doesn't matter how we compare. Yeah. I mean, the comparison itself is not implemented in the sorting algorithm, inside the sorting algorithm. The best case is we are implementing it outside, right? So dot compare is something like an interface, interface implementation of comparator, in which we can compare two items, right? Two items, either the left or the right. If the left is less than the right, then it will return a negative number. If it's equal, it will return a 0. If it is more than that, it will return a positive number. So as you can see here, this spatial number comparator, I implement an interface called comparator integer. So you might be wondering, why am I using comparator but not comparable, right? This comparable. Usually when we are implementing comparable, we will implement it in the same way as the class name here. Something like this. Why am I not using comparable, but I'm using a comparator? Right? Because the data structure itself, the class itself it doesn't bring any meaning, because we are using an integer as our as the things that we want to put inside, the element we want to put inside. It's not a specific class that we want to put inside. So implementing comparable, usually the class itself is a data structure. For me, in my opinion, right? So if this is let's say this is a student score that implements comparable, yeah, it makes sense because student score itself is used to it has some meaningful data that we need to use for sorting. But in this case, comparable will solve our issues already because comparator, as you can see, it accept integer and both are integer parameter. It means that it is not bound to any data inside the spatial number comparator class. So let's say if we have some integer x equals to 0, then y equals to anything. We are not using the data inside comparator. So it means that makes me think that implementing comparable, it sounds weird to me, right? So simply said, if you implement a comparator, it is used to compare things, right? Compare the first item and the second item. Inside the arrow function, you put the data structure that you want to compare. Then here you make it return like negative number or anything according to the question requirements. The first if condition is that, okay, if the first is odd number and the second is an even number, then odd number will definitely be smaller, then it will be -1. Any number below 0 will do. Then the second one is, the first is even number, the second is an odd number, then I'll return a 1. Right, return 1 means is larger, O1 is larger than O2. Then if there's none of these conditions, it means either both are odd number or both are even number, then I will go for O1 minus O2. So let's say O1 is 1, O2 is 2, right? 1 is smaller than 2. So 1 minus 2 becomes -1, is smaller number. So there's a reason why I can do comparison by simply minus it. Then the comparator is done. We just plug the comparator inside. The reason I can simply plug is because this is a static. I put a static variable comparator here. By means of static, it means I don't have to. I can use it in all the methods I have, regardless it's a static method or it's a non-static method, because this instance is always allocated a space. Then input the number, print out the sorted one, then we can get odd number first, then even number, right? Another way you can do is probably you implement, for example, you implement the spatial number. Let's say you have a spatial number class, then you can implement the comparable, right? You implement a comparable, and here probably you want to have a spatial number here again, then integer number. Then you need to have a spatial number here. The constructor that puts the and implement the condition compare to, yeah, then here you are doing the same thing. You just implement the compare to, then spatial number, because it can be compared already. So now instead of using an integer, you use a spatial number. But it doesn't make sense to me because we don't have to override much of the behavior of integer, right? So it doesn't necessarily has to be done in this way. But if you are doing it this way, it means all will be spatial number instead of integer, right? Something like this. Then you proceed with the rest. But it's lengthy and it looks weird to me as well. Right, so this is the first question. Stop me if you have any problems. Right. The second one is quick sort. Again, you can see the questions has some pattern here. I'm not sure if it's because of the as we are approaching the end of the lessons, the question seems like more straightforward compared to the previous labs. right? So it tells us to sort and give us the condition for sorting. It tells us to read input and sort by the condition of sorting, right? Sort and the condition of sorting, both are different questions, different requirements, right? So for these questions, we have to use a quick sort to sort by the P first, PID, product ID, then sort by the price first, right? So sort by the price, then PID, right? Price, then PID. So again, we look at the sorting algorithm first. Sorting algorithm for quick sort. Okay, again, pen. Array of 5 items. So quick sort, you can actually define the behavior yourself, but they have the command pattern to merge sort actually. So pivot means the element you are choosing. Let's say in the first loop, the first method call, I'm taking this as a pivot, right? So this is a pivot. So next, I will try to put this at the right position. Let's say if the middle is right position. By means of right, it means everything at the left side of this point is less than it, and everything at the right side is more than it. Right. So I will put it at the right position first, and after this, what will happen is that after I put at the right position, then I will divide the array into half to solve everything less than me at once, and to solve everything at the right side of me at once. Right? Something like that. So as you can see, the first one we have 5 items, but the second one we have 4 items only. Then where will this pivot go? Right? Because we are doing always remember that array, right? Array is always referencing by the, it's always being referred by reference. It means the same thing. All are using the same array. So if this is already at the right position, right, it means it's somewhere inside this array that is already correct. So we don't have to refer it already. We refer to the rest of items. So this item is actually still exists, but we don't care about it already. So that's why we only care about things at the left side and at the right side. Again, the same thing, selecting either of the item as pivot and put it at the right position. And after we put at the right position, ignore it because it's already in the right position. Right. Then we go to the left side until it reaches the stopping condition. Later we can check what is the stopping condition again. Right. After it reaches the stopping condition, I think it will do nothing and go back. Right. So we can ensure that these two are already sorted. And after this, the right side also the same. We find somewhere here and become one item. Yeah. Then all will be in the right position already. Let's see the algorithm here. Right. The stopping condition is when low is equal or higher than high, same thing as merge sort. We select a random point, or it don't necessarily be a random point. In this case, we are selecting the high, which is the rightmost item, as the point that we want to make it as pivot. Right. So this is the location, the index of the pivot at the right position. Then after this, we will do a quick sort. We will call this recursive method at the right side or left side of the array until the end. So remember just now, same thing as a merge sort. We will be finishing the recursion until the stopping condition first, only we will return. At the right side also the same. Right? We ignore the current point of our pivot because it's already sorted. Then we go to the left side, go to the right side. Right, so what is in the partition? So partition, it means that we are accepting the, so we are putting the pivot first as the rightmost of the item. And initially our I will be, let's say our low is 0, right? So the first partition is 0 until the length of array -1. So here we are putting it as, let's say, -1, I equals to -1 first. Then we look through the array that we want, the range of the array that we want to compare. Then if the item is less than pivot, I will increment the I. So I is something like a pointer to the location of pivot, the correct location of pivot. If it is, there are something that's less than pivot, it means it will go to the right, shift right once, and give the space to the item smaller than the pivot to be inserted at that location. So that's why if we meet anything less than pivot, we need to put it at the location of I, right? To ensure that it is less, it is somewhere at the left side of pivot. Still unsorted, but at least we know that it is less than pivot. Okay, we will do this until the end of array, then end of range of array. Yeah. Then we will increment the I again for 1 and replace the location of high. Array high is the original position of, this is the original position of pivot. This is the expected, the actual position that it is supposed to be. So we are just swapping it to ensure that the pivot from its original position will become at the right position, at the correct position. Then we return I plus 1, which is the index of the current, the correct position, right? I plus 1, I plus 1. Yeah, something like this. So this is for the quick sort. Simply said, find a pivot, put it at the right position, break into half. Find the pivot, put at the right position, break into half. Yeah, break into half, then you're done. Right, that's it for the quick sort. Then the second requirement again for the sorting mechanism. Not the comparison, right, between products. So our product, we have PID, SID, price, and quantity. Now I implement the comparable. This is the same concept as I mentioned previously in question 1, where in this case comparator is more suitable is because it is stateless. It doesn't have any variables storing any meaningful data. But here we have some meaningful data that we want to use for sorting. So it's more convenient for us to sort of implementing comparable to compare itself to other product. Right. So I will compare with another product. If the price is less than me, then I'll return a -1. If it's more than me, I'll return a 1. If it's 0, it means they are equal price. Then I will compare by the PID, the product ID. So dot compare to it will implement it will apply the default behavior of our string, means something like a alphabetical order, perhaps, right? Yeah, this is the comparison for the string by default. Then I will implement a toString method, putting the same thing, format it to the 2 decimal places. Yeah, that's it. Then I'll initialize the product, do a quick sort, then print out the product. Then you'll get something like this. Yeah, sort by the price, then sort by the PID. Right, as you can see 4, 13, when they have the same price. So as long as you are implementing the comparison method properly and you are implementing the sorting algorithm properly, then the end result should always be expected result. Yeah. don't mix them together. Yeah. Make them as a different requirements needed. Let's separate the codes. Right. So that's it for me for these two questions. I'll pass to Wai Xiong for the questions.
Okay, now go to the third question. So for third question, we're required to do a class we call a sort test to compare the performance of the five sort that you have learned before with selection sort, bubble sort, insertion sort, merge sort, and quick sort. Okay, so basically you will build a sort test that will receive the either the input array that you have input array with a random number, and then you put it inside the class, and then you have five method, maybe more than five method that represent the sort the sort algorithm respectively, and then you call the method to calculate the time taken to complete the sorting. Okay, for me, my sort test, I will accept a two-dimension array where the first dimension will be the set, and then the second dimension will be all the numbers inside the particular test case. So maybe you can put another constructor where the set number, integer of set number, and integer of size, and then inside here you use the random to generate. I put my random inside my main classes, so I already generate a two-dimensional array, and then I pass to this class. So then below that will be all the method that represent all the sorting algorithm. So we have a selection sort, a selection, bubble, insertion, merge, and also quick sort. So quick sort and the merge sort you have already done in question 1 and question 2. So you can just copy your algorithm from question 1 and question 2, put it into here. Reuse the code that you already written before. Okay, so now we go to looking at insertion, bubble, and selection. Okay, so for bubble sort, it's the first sorting that we learn in FOP, where you were just using two for loop to compare one by one, and then you just swap it uh, if they are not in the correct order that you want. So let's say if you want ascending order, but the first one is larger than the second one, and then you just change their position. So this one, since although you already change it, but the number might not in the correct position, so you need to have two for loop to sort to find the correct order of the element. Okay, and then for another one is called selection sort, where you start from the the first for loop where you choose the you look from a first index to a last index, and then you select the current index, and before it, if you have the sorted array, and then you compare each element in the sorted array, and you check whether which position it should be. Wait, oh, that's insertion. Okay, we go back to select. We go to insertion first. So just now I talked about algorithm for the insertion, where you choose element. So let's say you have so basically for the first time when you look through when you go to the for loop, so you have sorted 3 inside, and then for the second time you look for the second index with number 6, and then you compare it to the every element that inside the sorted array, where you see where it should be inserted. So it should be inserted last, and then you just insert, and then you repeat the process by looking for the at the third index with number 4, and then you insert it into the correct position of the sorted array. So at the end, you will get a sorted array. So basically, it starts from a first element, and then they sort it one by one. When they go to a new element, so they look for this element should be at which position, and then just insert it. So that's why I call it insertion sort. And then the next one, the third one, is selection sort. Yeah, I got a little bit of forgot for the selection sort, how it's work. Okay, so for selection sort, it's quite similar with the insertion sort, but the difference is you didn't differentiate the sorted array and the unsorted array. So in insertion sort, we will differentiate the sorted part and unsorted part, and then when we get a new element, and then we will take a new element from the unsorted array, and then we insert it into the sorted array with a correct index. So in selection sort, basically is we will although in selection sort we didn't differentiate the sorted array and the unsorted array, but you will see they have the part which have been sorted and also the part which is unsorted. So we use back the example here.
Presentation at 19, and for group 5, 6, 7, 8, and 9, we have presentation.
So basically, when you look through, the first one will be 3, and the second one when you get a number 6, and then you will compare it with the element before, and if the order is incorrect, so you will just you will sort it and repeat the process again until you find it the order have been in the correct order. So this one is already correct. Okay, so we go to the other one. Okay, so like for this one, so you will repeatedly doing the same process of compare with the before, unless it is in the correct order, or else it will just it will swap the two elements. So in this case, you will swap 4 and 6, and they will compare again. 3 and 4 already in the correct order. Or since the before one you already sort, right, so you don't need to do a checking. So it's can we say somehow is more efficient compared to bubble sort. Okay, any question regarding the 5 sorting algorithm? If not, we will go to the main class to show the performance of each algorithm. Okay, inside the main class, so just now I said I generate the 2-dimension array inside the main class. You may generate it inside the sort test object also. So that means you will pass two parameters. You will pass two parameters inside the sort test as a constructor, and then inside the constructor method you generate the test cases. So here the result is with the microsecond. Did it say in mass? The question didn't say what time unit we should use, so I'm using microsecond. So the time printed here is a microsecond. So as you can see, it is follow the theory that we learned, where the quick sort will be the faster one. So you may look through the algo list to see what's their order from the first to the last.
现在他讲的是20分钟的，所以说最少要这两个，最少要这两个，然后再讲回，其实好像也是我的理解啊，就讲你要讲这个 master of tools system demo， 你可以看。
Okay, so you can see the order. So based on our theory that the quick sort will be the faster one. So next one is the merge sort. The insertion and selection will be quite similar than performance. And then the bubble sort will be the slowest and less efficient among all the algorithm. But if you can play around the code, right, so you can realize that. So let's say if our array has only 20 elements, you might find that quick sort is not the most efficient. Instead, either insertion or the selection sort will be the most efficient. So normally for this one, the size of array were smaller than 32. You can see most of the time insertion sort and the selection sort have a more advantage compared to quick sort and merge sort. Until the size will become bigger, then quick sort and the merge sort, it will show their advantage over insertion and selection sort. Right here I play many times. So just now you can see the selection sort is most efficient. It's the most efficient algorithm, and for now it's a quick sort. By the way, the size for now is just 32, so the array size is quite small. But the size, as the size become bigger, right? So you can see the big difference between quick sort and the selection sort. So when you design your next application or your next program, right? So you can determine whether is your program need small size array or big size array. So if the size is like more than 32, you may not need to use the quick sort. Instead of using quick sort, you can just use insertion or selection, which is more efficient compared to quick sort and merge sort when the array size is small. Or else, if your program will sort the big array, we have a big size, let's say more than 32, like 100 and thousands. So you can use their default sorting algorithm, which is most of the language they will use quick sort as their default sorting algorithm. So which given the most efficient to your program. So any question? If not, we will go to last question. So for last question, I pass to Sia to lead the question.
Sia, are you okay now?
No, okay.
Okay. Then I will help Sia to explain about the last question, because it's having some issue for in his neighborhood. Okay, so last question. I'll share my screen first. Okay, right. Last question is about heap sort. Okay, heap sort is basically we are first of all we are making a tree. That the behavior of a tree is that the parent is always larger than the or both of its children. It means it's max heap. The largest one will always at the top, and the smaller one will always become the children. And here is some descriptions for the heap sort, for the behavior of heap. So it must be a complete binary tree. So the definition of complete binary tree, it means that the nodes will try to go to the leftmost if they can. So it means that it is scaled to the left, something like that. So the left side will be occupied first, then only the right side. Right, so it is using an array implementation in which we are defining that, okay, so the root itself is k, and the left of children of this k will be 2 times k plus 1, and the right of the children is the 2 times k plus 2. So by using the 1D array, you are able to achieve the behavior that's same as when you are using a list to implement the tree, for example. Yeah. Then sort some characters using a heap sort in ascending order. So heap sort visually it is okay. Heap sort visually it is it might be easier to understand, but when we want to code it, might have some issues, right? Five array of 5 items. Let's say this is our grandparents, right? This one. Then its direct children will be somewhere in 2 times k plus 1, right? 2 times 0 plus 1. So this is first children. This is second children. And if this has any children, 2 times 1 plus 1 is 3, 0, 1, 2, 3. So this is the 1.1 is children, and plus 2 is 1.2 is children. And this 2 times 0, 1, 2, 2 times 2 plus 1 is 5. So somewhere in the index of 5, but it's exceeding our limit of area already, out of bound. It means it doesn't have any children. So our tree will be, our grandparent is at the top, at the index of 0, and the direct children will be 1 and 2. And from 1, we will have 1.1 and 1.2. And it is to mention that this is the original array that is converted into tree, but nothing has been done yet. So our first step is to build a complete heap first to ensure that the grandparent will be the largest element. So it means at the index of 0, the number here will be the largest, right? So after we make it a proper heap, max heap, then it will be still the same size, still something like this, but the largest will be at the top, and the smaller one. These two are even smaller. Then the magic of, not the magic, the way of it doing the sorting is that every time it will bring the, if I'm not wrong, it will bring the smallest to top. So let me check again. Okay. Let me check again if I'm afraid that I might explain wrongly. So this one is do a complete heap first, then every time I will make I will swap the location of, I see. Okay, I know how it does already. So now we are doing the sort name heap sort. Right. So this one, we can only ensure that this is the largest one, but we cannot assure that these children are small, are at the correct position, right? So the things we can do is that we put this to replace the root, and we exclude the maximum into the sorted array, because it is already confirmed that this is the maximum number we can get, right? So at the end, it will be something like a tree that only left 4 items, 1, 2, 3, 4, and the rest, the missing one is the original grandparent. The grandparent will be put into a sorted array, something like this. The grandparent will be here. Then the rest is still unsorted. The rest of 4 items is still unsorted. The maximum will be put here. Then we'll do the same thing. After we heapify it, after we make this as a complete heap, then we will extract the grandparent out and put the child to replace it. So it'll be something like 1, 2, 3. And here, the array will be sorted, and these 3 are not yet sorted. Then we will do the same thing to make it become 2 items and eventually become 1. And it will be put inside here, and the resultant array will be sorted 1. Right. So the way it does is it always construct the max heap and extract the maximum number out by replacing the children and itself to ensure that it is at the rightmost position, because we know that the rightmost, bottom rightmost child is the at the rightmost position. Okay, what I mean is that as you can see, this 1.2, right? This 1.2 will be at the rightmost of the index. So if we replace the grandparent here, and this one become 1.2, it means that the right side is sorted, right? The right side is sorted. So the same thing, if we replace 1.1 with the grandparent, then the grandparent will be at the second most position. Until the end, we should get an array of the same size as n. Right? So what the algorithm it does is that we can go through the method for heap sort. Okay, first of all, how many times we need to do heapify? So heapify, we need to go through the heapify first. So heapify, it gets the index of root and it gets the n, and what is n? I think this is the last index of the range of the array that we want to do heapify. You think? Array 0, array I. Until n. Okay. I think this means the range of the items that we want to sort, but let's check later, right? So get the largest index. Initially the root is I, then the left child of this I is, so heapify it takes three items. Actually, the first one is the parent, which is originally they call it as largest as I. Then the left child is L, the right child is R. By doing the 2 times k plus 1, 2 times k plus 1. Then if it is less than n, it means the index of L or index of R is still within the range of array. Because it might turn out that for example, like we get a 2 as a parent, right? 2 times 2 plus 1, 2 times 2 plus 1, it exceeds the array size already. It means it doesn't have any children. Right? So if the children exist, if the child exists, and it is larger than our initially largest index. So for example, L is larger than the item at I. It means the largest is not I already. The largest is L. So they change the index, like the largest become L. But again, we are checking for the largest. So let's say currently L is larger than I. We found that. So this one will become largest, right? Then what we have to do is we compare the largest to the R. If it is exists, the child exists, and it is larger than the current largest index, then it will replace it to become largest. So let's say if this is the largest one, it will become the largest. Notice already. Now, after we got the which one is largest, then we replace the we swap the current largest index to the previous I. So this is the previous parent. If we found that our largest is the child, then the child will be swapped with the parent. So this will actually become the previous R item. This will become the previous I item. So at the end, by given 3 items, we are able to using the heapify to ensure that these 3 in the first recursion, these 3 are the parent are at the top. Then it will also go to the bottom-up approach. As we can see, if the largest is not equals to I, it means that if swapping occurs here somewhere here for the parent, it means the value here is different already. So it needs to go to the upper side and find that if heapify is still needed, if swapping is still needed to ensure that the the largest, which is to ensure the parent here, the new parent here, at the right position by looking up at the next heap. Then we will check again, then go up and check, go up and check, and eventually it will be at the right position. Might be a bit unclear. I also a bit unclear. Yeah, something like this. The way it does things is something like this, but the details maybe you need to check again, right? I'm afraid that I'm telling the wrong thing. So first of all, it doesn't necessarily have to heapify everything. If you want to heapify, because the reason is that it goes from n divided by 2 minus 1 is that the bottommost children, the L and R, the previous one, the 1.1 and 1.2, we cannot do heapify actually, because heapify it needs at least 3 items. So you start from 1, 2, and grandparent. By bottom-up approach, from bottom to top, you go for 1 first, then you go to 2, then you go to the parent. Right? No, you go to 2 first, then 1, then parent. Right? From the right until the left. N divided by 2 minus 1. N is 5 divided by 2 is 2 minus 1 by 1. It won't go to 2. Yeah, it won't go to 2. The n divided by 2 minus 1, it will exclude everything that doesn't have children, apparently, right? So it will divide like this, and only heapify 1 and the grandparent. Yeah, only heapify the 1 and grandparent. So the first, let's say if we only have 5 items, it will only do heapify for these 2 to ensure that we are getting a max heap. Then after this, we will have to do the things that just now I've mentioned, which is to exclude the max item and put the child at the topmost to to eventually achieve a sorted array. So this one, it will be n times, which we go from the n first until the beginning, n minus 1 until the beginning. Okay. Usually we will not use heap sort as compared to merge sort or quick sort, because it is more cumbersome to implement, and it is not very efficient as compared to the complexity it has to implement it. Right, it's more error prone, and quick sort or merge sort might be faster than it. So the question itself is not difficult actually, but just that we need to get some input and implement the heap sort, and yeah, it will be sorted like this. But the complexity is the understanding towards what is heap, the heap data structure, as well as how to implement, how to apply it to help us in sorting. This thing for now also, I'm a bit unclear about the actual implementation here. So if you have an idea, then probably you can help me to explain about this part. I might need to do some study again to recall what is the actual recursion that is being done here. Yeah, don't want to explain anything wrong to you. So that will be for question for heap sort in ascending order. So that is the end of the lab. Okay. I think just now you have got the information about next week YWA, which I didn't. I wasn't here just now, so later I will align with Asia for to know how is the procedure that we are going to do this YWA session. That's that if you haven't completed the assignment yet, which I think most probably no, we're done. But remember that the time is the most important thing. It means even though if you are if the result of your assignment is not that beautiful, but at least ensure that for my part, I think that you will need to log everything that your program does. At least system out print line, everything, every logs. As I've previously mentioned, you are doing a kangaroo, then make sure that you log each and every procedure and you are able to explain why is this happening. Then ensure that you hit the basic requirement then enough already. The data that you are using, the way you are, the simplest form is that you are just using a console application, it will be fine. Just make sure that you fulfill the requirements first. Yeah, don't stress yourself fixing the bugs due to some UI errors, because when things come to the UI part, and it is not uncommon that because you want to implement some kind of UI or animation, then you end up having some weird bugs because of mixing up the UI logic and the core logic together. There will be one of the possibility that happens to turns up an error because of the operations in UI is usually concurrent. It means the things that is run, it might be initially it might have to be run last, but it turns out that it runs first. These kind of things. So ensure that the concurrency issue doesn't happen first, then only you worry about the UI part. Slowly. I mean, don't stress yourself too hard. Yeah. Still early. I wonder why we are having less and less questions already for the later labs. But if you have any problems, then we can discuss together then. Or any kind of problems in assignment also can, or in lab also can. Yeah. Have you take the remember to take the attendance if you haven't done. Not take the attendance, to write down your name and metric number. Okay. What else? Right, so time is a major. Oh, you're okay already?
Yeah.
Okay. Yeah.
I explain the part that you say you know. Okay, I will put there.
I'll pass to you.
Okay, I try to explain it fast. Okay, so actually, Heap it has two way. What we are doing now will be called as the mass Heapify. So it is sort the largest node at the root, and then for if the other way is the min Heapify, which sort the smallest root node at the root. Okay, so for the heap sort, first you need to build the mass heap first. So for this statement, the first for loop, actually it starts to sort from here. This is the example I get from the question, the character. Okay. So it starts to sort from here. Why it starts to sort from here is because here have the this is the last node they have the children. So it try to sort check if this node is actually larger than its children. If is largest, then you do not need to change. If it's not, then you need to go you need to change it. And then if you move to the next one, which is the X, then you will check again with its children, and then you will sort. And then you go to here. This one also is larger than its children, and then this one it will change. It will change with the largest of these two children. So you after checking, it will be exchanged with E. Exchange with X. E will exchange with S. And then inside the mass heapify, actually it will try to sort it again, because we're not sure that this node after replacing is actually larger than the children of the X as well. So it will call mass heapify again to sort it. So after checking, it will be exchange with the N. E will exchange with N. So now E move to the bottom of the root. And then for this one, so lastly it will check again for the root, and it will exchange, and then exchange again. So now a mass heap is built from for the character array. And then for this one, for the second loop, actually is changing this to this. So the root of the mass heap, it changed with the last node. And then it actually is removing. Actually, it's not removing, but it's like it did not try to sort it again, because it knows that this one is already sorted. Because this is the mass heap and the root is always the largest, so it did not try to sort it again. But now it will try to sort the remaining part of this mass heap. Okay. So for the first loop, actually it tried to sort from the bottom to the root, because if this one will be the fastest way to quickly sort the heap. But for this one, actually it start with 0. It try to sort based on the root. This is because that actually here for the other node, all of it already being sorted, and then but this one is haven't sorted, so it start from here, then it will jump down again. And then it will jump down again. So now this one is the second last element, the mass heap for second last element, with this being excluded. You can see that that is why it used that I equal to mass size minus 1. Because you want to exclude the last node. And then this one will be replaced to this one, the last node. The last node is J currently. And then you exclude again this node. So what is different for heap and the binary search tree is that for binary search tree, actually it did not have duplicate element, but for heap, it can have duplicate element and it still can sort it. And then when you print out the array, actually you found that it's not the message is not sorted in order. Is actually the parent must be larger than the children only. So you can see that V is here, even though even though in front the T and P is smaller than the V, but V is actually smaller than Z, which make it a legal message. Okay, that's it from me. Is there anything you all want to ask?
By the way, I'm not sure why recently so many news about so many advertisements about the rise in rankings in the QS ranking. But probably we can think in this way. Most probably we are not the contributors of this race in QS ranking. So shouldn't be thinking that it is something that we can proud of. No, it's just in my opinion. So everything still remain the same. Still focus on improving ourselves. Then this ranking is actually nothing based on our situations. Yeah, nothing to be. Yeah.
The ranking show us how important is know the schema.
Yeah, it's a example of hitting the marking scheme. Then you get high scores. So make sure that you look into the rubrics if there are any for any of your courses before you do a presentation or demonstrations. It can help, probably. I think we can discuss 30 more minutes. Issues when you're writing a program, make sure that you can follow the behavior, the way we are thinking about breaking down problems into sub problems. In assignments also we can do by breaking down module into sub modules and solve it one by one, then only merge together. So in anything anything in your assignments also, as long as it's a team project, then it should be able to be broken down into pieces and solve the puzzles one by one. Don't do everything in the main method or do everything in one class. Try to break down the problems. But it's always a good practice to find out what is the best practice of your project structure. Yeah, before you write your codes, then you lay out your structure first. Or now if you have done your assignment, then probably you can try to clean up your codes. Remove all unnecessary comments. Remove the classes or the methods that are not in use. Even for example, if you are making a class that the items is never used. It means the getter or the setter is never used. Then you can just simply remove the getter or setter. Make sure that your codes are clean as possible. Unnecessary comments of codes can be removed, but comments on the methods or comments on the particular lines that you think are important to tell us what to do, then probably you can write them down and ensure that, for example, if in my case, when I'm doing the assignment, usually I will use the, but for my concurrent assignment, I'm using a simplified version of MVC, which I'm not sure whether it's a correct or incorrect way of model view controller. But the project is structured like this. So I have the FXML file, which is the design of the interface. The design of interface are all put in one folder. And there are things that controlling the UI behavior and also sending the request to my core business logics. That part I call it as controller. So controller is another folder, which inside have bunch of controllers that can control the behavior of UI and able to get the request and get the payloads and send the request to another layer. So there's a controller. And I think and the core business logics, they are all in the folder name model, right? So there are like 3 layers of relationship. The topmost, the UI is view. The things that control the UI is called controller, and the underneath business logic is called model, right? So, but my style of coding a project structure is a little bit mutated by the way I'm using for. I think it's another design pattern. I'm not sure, but my object, all the objects like, for example, like you have kangaroo class, then that all the objects with only attributes but not difficult methods, those object classes I will put inside a folder named DTO. So I know that inside there are all some class that don't have dependencies on each other or something like that. So it can be clean and easier to work together. So it might be too late to just use a way that you and your team are familiar with and agree upon. If you have time, then try to structure your reports in a way that it is readable and it can relate to your project, right? So report is actually not just simply right, but also with justifications behind, with assumptions behind, with some logics that makes you want to code your program in that way. So you can start thinking as a report is something that can can reflect your program and can help you in understanding the program. That is the core reason why we have to write reports. It's not only just to fulfill the workout requirements or something like that. There must be reason behind everything that we are required to do. Usually there are reasons. I hope you are doing well in your house and in any way. So these are probably we are not going to have a study week, right? So make sure that try to control everything as possible first. If you have any issues, including some mental issues, then you're fine to discuss together, right? So if you think that you are suffering from e-learning, actually everyone is suffering, and For me, my final year project, we have to do video presentation this Sunday already. But yesterday is the first day I start coding my final year project. Yeah, that's how tension the situation is currently, due to the amount of assignments that we have to complete every day, the amount of reports that we have to write every day. Software engineering students have damn a lot of things to write. Like if you cannot blow 20 to 30 pages in one day, then it will have issues that we can't produce a proper assignment, because the word count limit is like that. We need to write like 10 something pages, 20 pages, and the time given is really limited. So if you don't know the purpose of that report, then it is impossible for us to bluff according to requirements stated in the requirements of assignments. If you have time, just find some time to grow yourself, to expose yourself to more things, right? If you don't have time, then as well, work-life balance. Yeah, I can see that I think everyone can feel that way. Like in many places, people are getting more stress in social media. So that's the current situation where we can say that the entire system is, maybe the academic system is not yet ready for e-learning, and it is very hard for lecturers to estimate what is the evaluation, how much efforts that students have to put inside for every courses. So because this is the first time we are doing e-learning everyone is adapting, and there are situations where the estimation of the time needed is a little bit too strict as compared to the time we have every day. And probably when you are at home, there are things that you have to do as a child. There are things that you have to face as compared to when you are in hostel. You can manage your own time. You can have your sweet time with friends. But at home, everything will be different. Like the time given, if you wouldn't want to be a robot that works in front of a computer every day and not talking to your family. Yeah, I think they will complain about it also. This is my current situation. So my family has gone to my grandma's house now, but I found that I don't have time to go there already. So I have to stay at home and continue with coding the final year project, which is ridiculous. I mean, the everything is in balance now, but still we need to cope with it. If we don't, then nobody will be able to help us. Yeah, quite depressing, but yeah, just remember that we are not the only one who feel that way. Just think that way, maybe it can let you feel better. Think of any way that can make you feel better.
Hope you all listen to Jia Xiong's experience. Don't drop the course.
Yeah, you don't drop the course, and you don't try to drop yourself from the roof, something like that. Yeah, there's no need to feel to try to harm yourself because of the stress that you have. Right. Everything can pass on. You might be stressed out these few days, but once everything is cleaned up, then yeah, things should go back to normal after this month. It's not a long time. I think I mentioned already, because every time when we have lab sessions so long time, then I don't want to say, then I just So for your everything that you have done, if you feel that you don't have time for perfections, then there are trade-off. So don't expect yourself to be perfect in every aspect. Don't expect yourself to be perfect to be ready for the challenges or for the submission deadline. Just ensure that you achieve the requirement first. Then forget about the assignment already. Put the aside and move forward to another challenge. Don't look back for the things that you have done not that good, or don't feel bad for the examinations that are not yet coming. No. Make sure that before we become a good student, we are a human. Okay, so human will need some kind of things that entertain us, right? Some entertainments that keep us as a human instead of a robot that does job every day. And yeah, make sure that you know the purpose of yourself, why you are working so hard now. No problems? Any problems? Because recently, there are juniors who come and find me regarding mental issue. But I really cannot give any advice because I myself, I'm also having some mental breakdowns recently. So all we can do is to listen each other and try to listen and try to make them try to feel like we are not alone. Right. If you're feeling too overwhelmed, then I think it is okay to not take the grades as your priority. Start if you up to now you're thinking that the results are the only thing that you need to take care of, then try to not feel that way, because now we cannot control already what grades we will be getting for our the time we spend it not necessarily help us to get a good grades, because we don't even are exposed to the utmost to every lectures or every tutorials we have. So changing your priority might help you in easing up your stress. Right. 17 more minutes. Anything related to programming you want to know? I mean, related to programming. Yeah, else I feel I'm useless as a demo here. Yeah, so data structure is it can be pretty fun actually. Yeah, simple test. Doctor, do we have that simple test, or is it compulsory to submit? I'm not sure what simple test you're mentioning because I don't have access to Spectrum. So, Doctor,
I think it means sample test for the assignment, maybe.
Simple test for assignment.
I'm not sure.
Oh, okay. So yeah, we shall confirm it later.
Actually, from next week, we start evaluation of assignments, DS assignment. So I'm going to announce the instruction for assignment submission and presentation. For DS assignment submission and presentation, maybe by few minutes I will announce it. Then in next week we start the evaluation of assignment from 9 o'clock. From 9 o'clock we have 4 groups for next week and the remain one for week 14. I need your help, the most help for evaluation of students, for evaluation of their assignment. And I will let you know how is our evaluation, and I will let you know the slots and the details. Through WhatsApp, I will let you know about it, but the students can see the details regarding their presentation and submission, what they need to submit, what they need to present, what time they need to present through a spectrum. Okay, any question?
Yeah, but by the way, the presentation, I believe that some of you may be using mobile application. Yeah, then I need to think about it also. How you want to present to us regarding the program that you have made. It might be unclear if you just open the video and show us the.
Yeah, thank you. Yeah, if you know that, for example, you need to say any note regarding their presentation or their submission, please let them know, because you are the main evaluator. So just let them know what they need to do and what they need to present for the next week and week 14. Thank you.
Also, if you have any issues, like members unable to attend or network connection very bad, then probably need to let us know first, so we can do something to probably find alternative for you. By first email the COVID team for HEPA first, from HEPA first, then get their email approval, then only contact your hostel fellow and let them know that you are going back to take a staff and return the key. Yeah, follow the SOP probably, else you might be blocked outside the campus. Right. You can start applying if you already know the time that you are going back to do to take your belongings from the hostel. Right. Okay. If you have no problem, then we cannot help. Maybe your team members can help you to cover up. But make sure that you let us know you have no problem. you haven't recorded your attendance, don't forget to record it, else your attendance will not be taken. Then even though if you attend the section also, we cannot trace back when you attend. Then you also have attendance issue. If this week and if next week and the coming weeks is the demo, no, it's a demo for your assignments. It means today will be a last day of discussing a lab session. Then the rest of the labs you need to have fun trying yourself. Yeah. Not sure how long will each presentation take. If it is only 1 hour, then probably we need to discuss about lab again. Yeah, we'll see how. Oh, by the way, sorry that if I there's a long time since the last time I updated the YouTube. Because of the time constraint. Yeah, and there are times where even though if you're there are times where even though you are not that occupied, but you still want to have some personal space. So this is the situation. So I didn't update for pretty long time already. But still, if you have any specific issues that you want to discuss together, then probably still can try to find a channel to find me or any of demonstrators or lecturers here. Because of you can think of the relationship of us as the developers and the users. Yeah, so we are the users. We give you these requirements to do the task. You are the developers. Only you know the complexity of the task given. So we as a user, we don't actually feel that way. So if you abilities of communicating with us, right? Of us to let us know what's your problems, then only we can help you to resolve it, or we can find a workaround to resolve it. I think this is a doing no these two into task. The best way is not to write confession, is to confess with the lecturer, right? You write in UM confession, there's no oh, maybe I shouldn't say here. Not sure. Yeah. I think that because we are given that assignment for a very long time already, so we are supposed to do that assignment to have sufficient time to do that assignment. But the reality is that at the time we are given the assignment, maybe we are busy with other assignments. But that's the point that see your faces. We don't see if you are crying or you are laughing. Yeah. So that's why the expectation is that we have given that assignment since, for example, since last month or last 2 months. Then you are supposed to be able to come up with the solution. That is the expectation. The reality is that maybe the actual time that you have the time for the assignment is like 2-3 days before the submission deadline. We don't feel that, so you can tell us that if you don't mind, right? If you have any issues, anytime before the presentation is not considered too late yet. I didn't know that you need to draw diagrams. Why do you? Okay.
Sorry to interrupt you. I already mentioned about the reports also, what you need to include in your report. And Sia and other demos, I included 2 links for their assignment, for DS assignment. I will show you Padlet link. You can see, I will share my screen, then you can see it. Okay, can you see this? This is the link that I provided for their assignment, for grouping of DS assignment and so on. So here we mentioned the group name and the topic that they are doing to do it. Then I mentioned the time of their presentation and the time of submission. Here also, okay, they can see the time of submission and the time of their presentation as well here. And we have a section here, communication of groups and instructor. Sia and other demos, if you have any point regarding their presentation that they need to know about it, just you can add comment here and you can write for them here. I already mentioned something about the evaluation and submission of their assignment and presentation through a spectrum, and I copied to the class just now. But if you have any other things that they need to know for their evaluation, just you can put here, because maybe you don't have access to a spectrum and you can not announce them through a spectrum, but you can add it here. Did you understand? Did you get it? Okay, PPT file is your slide and PDF file is your report. You need to provide a slide to present UML diagram and the introduction of your work and the methods that you applied in your work. First, you are going to present your slide, and after that, you go to show your program. And what you need to submit to me is your slide and your report. You need to submit your report through PDF file. So the PDF file is your report and PPT file is your PowerPoint file or your slide file that you are going to present in presentation time. Is it clear?
Dr. I think point 4 is missing from the summary given by Dr. just now.
Pardon?
Point 3, yeah. Point 3 is design and implementation. Point 4 is missing out.
Yes.
Yeah, the message that Doctor has sent just now. What
Yes.
you need to the point 4.
Here, you mean here?
Yeah, the point 4 is missing.
Oh, okay.
Yeah.
A screenshot of output.
Oh, okay.
Yeah. It's in a spectrum is okay, but here I don't know why it doesn't pop it. See, this is what I announced them through a spectrum. See, the point 4 is output, that they can include the screenshot of their output in this section.
I see. So they are required to come up with UML diagrams. May I know?
No, not all the diagrams. Maybe 3 diagrams is okay.
How can we define 3 diagrams? Is it
The UML diagrams.
Is it like activity diagram 3 will do, or a different type of diagrams?
Any type of diagrams is okay, but they need to choose 3 types of diagram, UML diagram for presentation. For example, maybe someone wants to include class diagram, another one a state diagram, machine diagram, component diagram, deployment diagram. We have different types of diagram. They can choose 3 of them and include it in their report and present also in their slides.
I see, because I believe that they haven't learned any diagrams yet. So, yeah, so not sure if this requirement is too difficult for them. Not sure.
Okay, they didn't learn diagram yet, UML diagram?
I believe that the subject is in 2nd year, which, okay, yeah. So,
okay. So it's easy. Just I don't go through detail, and I don't want a wonderful UML diagram. Easily through Wikipedia or any other resources through internet, they can see what is UML diagram, and just they can draw UML. But UML diagram should be drawn before the project and topic.
yeah.
After that, it's doesn't happen. After we conduct the project, we start to draw UML diagram. But it is a good practice. It's a good practice for the next year. Then you can see the relate of diagram and the topics. Because they don't have a UML diagram subject yet, we don't have much mark on this section, but it's good to practice, and it's good to be included in their report.
I see. So for my suggestion, I think that the easiest diagram to implement is use case, class, and activity diagrams.
Yes,
so,
yes.
Yeah.
Use case diagram, activity diagram, easily they can do it. Yeah.
So basically, use case is to tell us the requirement of the system within the system scope. Yeah, the program scope. What can it do? Class diagram is just to list out all the classes that you have used and the communication among them. Activity is to tell us the something like pseudocode, the flow of your program. Yeah.
Yes, thank you. Yeah. Component diagram and deploy diagram also are a general diagram that give the general view of your program, and they are easy. Maybe you have only 2-3 objects to be included in deploy diagram and components diagram. So just go through UML diagrams and choose 3 of them and draw for your project. It should be drawn before conducting the project, but it's okay. If you didn't you can do it now to see a general view of your project.
Yeah, just try to relate as close as and relevant as possible as your program. Yeah. So the diagrams are not simply drawn, but they have some meanings that relate to your system design. Still, it's not within your syllabus yet. I believe that we were not going too strict for it. So try to learn. Probably next year only you will see what's the use of those diagrams.
Yes. If you don't have any question, we can terminate the class. Okay, thank you, Demos. Thank you for your help during this semester. I really enjoyed your explanation and your work. I hope the best for all of you.
Thank you.
Thanks. All the best for your coming presentation for your assignment.
Pardon? I already mentioned all the details regarding their assignments and everything. I also will copy in the Padlet, then they can see it. Thank you to all. Thank you for super duper students and demos. I was really satisfied with your online tutorial class and lab sessions. Thank you and have a nice weekend.